programming for cause and effect in having 350 devices on the loop. There are instances where we need to increase the number of loops. There are even instances we have to increase the number of panels for you to achieve the cause and effect programming. And I do not talk here standing in terms of theory. I have personally experienced in many large projects in Dubai, where we had gone in for probably over 31 to 32 panels networked with a very complex cause and effect programming on with a combination of fiber, copper, and its kind of massive installations has got a lot of requirements in terms of cause and effect, and for which you really cannot. I do remember there are, I had to add on a panel just with one loop and another 50 devices just to ensure that we achieve that particular programming requirement. So please remove this from your mindset in terms of asking this question in terms of how many devices is going to be included in a loop. Because what you as an installer, you as an end user, you as a consultant, and you as a contractor, you need to really worry about the type of devices you want to mount in risk area and what cause and effect you need to achieve your evacuation plan. And I hope I answered your question. And if there is anything you want to ask further, please feel free to talk to me after the session and we can discuss about it. Any other question? Yes, sir.
My name is Vinayak Sane. I work as a consultant. One thing usually which is forgotten when you install a fire alarm system is a battery backup. Now, with this panel with number of features as explained, what would one should take care that in case of the UPS supply not being there, there's a power failure and the system has to work at its optimum, what one should do to create a battery backup and what should one look into it?
So if I understand the question correctly, you're saying how to implement battery backup for the system?
And what should be the rating? How do one calculate it to see that all the features work in case of power failure?
Great question, actually. A little bit surprised that I heard it. Maybe I've got some insight into something from the industry that I didn't actually know. Obviously battery backup is done within the panel itself, and you have expansion cabinets. So if you need extended power within the cabinet itself, you can support 3 amp charger up to 75 amp hour batteries. With respect to the calculation, how do I know if 75 amp hours is enough? We provide a battery calculator, which is a very simple to use utility. It's an Excel sheet that you input the number of devices that you have, the notification appliances. The utility has been programmed with all of the standby currents, the alarm currents required for both normal operations and alarm condition, and automatically it spits out the exact calculation on a node-by-node basis for your project. So it's pretty straightforward. It's automated as much as possible. You enter in the quantities for each of the various devices you're using, and it gives you the number. Purchase the battery, install it, and you're safe.
So it has to be purchased by the installer?
The utility?
Yeah.
No, the batteries you purchase.
No.
The utility is included free with the panel.
Yeah.
It's battery calculator.
Okay, thanks.
If you speak nicely to Dominic. Within this panel is 75 amp hours. Yeah, okay, thank you. For the 900 watts, one is the amplification unit within this panel has its independent battery supply. Each of the expansion cabinets also support their own distinctive battery charger and battery units within the cabinet themselves. And we have a picture. We don't have a picture of the expansion cabinet, but every expansion cabinet that you add has its own independent charger, transformer, and battery.
And how many zones can be configured in a mass notification?
Another interesting question. Verbiage is a little bit different, but zones are unlimited. You can do as many as you can dream up.
How many text messages, alarm notification messages?
Text messages are something that requires a little bit more discussion, not because I don't want to discuss it with you, I'm more than happy to. However, the tool provider for the text messaging will specify their own throughput. As a matter of interest, you guys as designers, system integrators, have options to choose which tool provider you want to use for sending out the text messaging. Most databases support unlimited number of users, unlimited levels of text, unlimited number of text messages. There's always going to be a throughput. When you get into the text messaging aspect of mass notification, there's some dedicated setup that has to happen either on the server or on the data center, such that you're ensuring that one, your messages aren't blocked as spam or mass marketing type messages, and two, you've purchased the appropriate number of trunk lines to send out those SMSs, emails, or IVR callouts. So it's a little bit more of a complicated answer, but I'm happy to discuss it with you further and point you in the right direction.
Yeah,
Is there any limitation of text messages, text characters?
The text character, again, depends on the tool. Generally, it's 40 characters, but you can send multiple text messages and sequence them.
Thanks.
Thank you.
yeah, there was one question. My name is Satish Iyengar. You said that your panel is web-based, all the controls. Now, in the web-based,
The
yeah.
diagnostic utility is web-based.
Now,
Yes.
what is happening is in the BMS, which we design for multi-locational buildings, multi-locational installations, we ensure that the BMS is also multi-locational, and the control is possible from a central facility. Is this panel, MMX panel, also integrated with that? The control feature, I'm talking the control.
The control feature
Yeah.
over the BMS interface.
Yeah.
So I'll talk about the control feature on the OpenGN interface. It can be distributed throughout a building, no problem. If the front end of your BMS is the OpenGN workstation as you saw, the OpenGN in modularity, you can have one master attached to one node, and then I think we specified at 32 slaves per master, but practically it's
No,
unlimited.
you are
as
talking
well.
only at one location. I'm talking at different locations coming on from the web.
So I'll explain, there's two architectures. One is locally as slaves. The other is remotely across a network. You can install a remote workstation per node anywhere in the world. So for example, if you have a network of 15 fire alarm control panels, you can have 15 master workstations. You can have one master, 14 slaves. You can have 10 masters, 5 slaves. It's up to you. They work as parallel independent networks, coordinating their activities independently from the fire alarm system itself.
All on the BACnet protocol.
The OpenGN uses either the proprietary web service protocol or the BACnet protocol.
Now we need the BACnet.
The BACnet interface itself is an Ethernet connection, which is a Cat5 connection directly onto the panel main board. You'll notice on the main board there's an Ethernet port. In the configuration utility, you simply specify the IP address for that panel, your gateway, and your mask, and connecting is as easy as opening up your web browser, pointing to index.html, and you have the web-based diagnostics utility. On the BACnet side, the BMS integration, same thing within your tool, so you specify the IP address of the panel. We use by default port 47808, which is industry standard for BACnet. Your points are automatically populating as the events are happening on the panel itself, assuming that you've implemented and allowed for BACnet services to be running on the control panel at time of configuration.
For every loop.
Can you
Length of
repeat?
the loop.
For the network loop,
Yeah, for every loop, what is the length of the cable?
we specify 4,000 feet.
4,000 on the return loop?
Redundant Class A, yes, 4,000. Oh, the SLC length. What is it, Ratish? 2,000? No, not kilometers. 3.3, 3,000 feet. 3,000 feet. Kilometers is long distance.
But
You
what
get
is
to
the size
Canada
of
on your SLC. 3,000 feet for your SLC. $3.3 meters. On the SLC loop? Oh, the SLC. 3.3 kilometers. My bad, Indian. Apologies.
That is, with what size of the cable? What should be the size of the cable at 3.3?
You can tell how often I do the installations. 12 to 16, correct? 12 recommended. We do testing within our UL facilities. We do the full length of the loop. However, we wind it in a coil.
No, this distance is basically depends on the number of devices and the induction capacitance of the equipments. No, we have practically we have found many times the distance is more theoretical, and it is a more number of devices are increased than distance is to be reduced. 3.3 kilometers practically is not tested.
Practically,
And
I would not use it. If you're asking me, I would practically go 1,000 feet on an SLC. But if you want to know the capacities, maybe Ratish has done some testing locally. Best design principle is to use as short lengths as possible. Reduces, like you said, the drop on the line. Practically when you're installing in the building, depending on building codes, for example, in Canada, you need an independent loop per floor. The floors don't go very far. I wouldn't recommend going 3 kilometers in any case on an SLC. But it's based on design, it's based on what else is in the building, it's based on a lot of different factors. So, if you want to talk about extremes, we can provide you the manual for specification. Otherwise, best practice is go as short as possible. 1,000 feet is very safe on your SLC.